All right, this is a supplemental video, an extra video for talking about section 2.5 or for explaining 2.5. Factoring quadratics of the form ax squared plus bx plus c. In section 2.5, we made sure that a was 1. So one of the things we have to understand is how multiplication works. So remember that when we multiply x plus 4 times x plus 5, we use the distributive property and we get x squared. X times x is x squared. We get a 5x that we're adding in. We get a 4x that we're adding in. And we get a 20 that we're adding in. So notice where the x comes from. Notice where the x squared comes from. It's x times x. Notice where the middle term of my product is coming from. It's the 5x plus 4x. So 5 plus 4 is 9, so we get 9x. And notice where the 20 is coming from. It's the positive 4 times the positive 5. Now, on this one, the only thing that changes is we have the x times the x creating the x squared. We have a minus 5x and then a minus 4x. Negative times negative turns into a positive 20 again. So the only thing that changed when both of these signs are negative is that we have a minus 9x instead of a plus 9x. But notice again that this is the product of the negative 4 and the negative 5, and this is the sum. The negative 9 is the sum of the negative 4 and the negative 5. When we do this one, the x times the x is the x squared. We have a negative 8x, and then a plus 6x, and then a minus 48, because positive times negative is a negative. So x squared minus 2x, negative 8 plus 6 is negative 2. So again, notice where these numbers are coming from. The negative 48 is the product of the 6 and the negative 8. The negative 2 is the sum of the 6 and the negative 8. Finally, this last one, x times x is x squared. I have a plus 8x and a minus 6x and a minus 48. So x squared plus 2x minus 48. The negative 48 is the product of this negative 6 and the positive 8. And the 2 is the sum of the 8 and the negative 6. If we understand where those numbers are coming from, it's going to make factoring easier. So what I want to do is I'm going to switch over to our notes and talk a little bit about the very last page of the notes has a lovely summary of how we factor x squared plus bx plus c as a product of two binomials. That's our job in section 2.5. Taking a trinomial of the form x squared plus bx plus c and writing it as a product of two binomials. The examples that we just looked at are helpful as we look at this. So the relationship between the b and the c and the signs of our different factors. So let's look at what we have. If c is positive and b is positive, then both the p and the q are positive. That's this first example right here. X squared plus 9x plus 20 factors is x plus 4 times x plus 5. Notice the factoring is undoing the multiplication, or we're going from the expanded to the product. To factor something is to write it as a product. So can we take that and go the other direction? So if c is positive and b is positive, then the p and the q are both positive. That's this first example. The positive 4 and the positive 5 are what we have in our factored form, x plus 4, x plus 5. If c is negative, whoops, we're not there yet. If c is positive and b is negative, then both of the binomials have a subtraction sign in the middle. That's what that is saying. Or the numbers p and q that we find are both negative. If c is negative, like in either one of these last two cases, c is negative 48 in both of them, then the factors have opposite signs. We have one that's positive and one that's negative, right? A positive and a negative. Again, on this one, they're opposites. One's negative, one's positive. One has a subtraction sign, one has a plus sign. That's what they're talking about. So we're going to go and do some examples right here in the notes. And I'm going to take a look at x squared plus 10x plus 16. Actually, you know what? I think I'll go back to my smartboard and we'll just do them here. So I'm going to do it a little bit differently than in the previous video. So I'm going to take x squared plus 10x plus 16 and show you a little bit different way of factoring that. So the first thing I'm going to look at is, this is my c value. C is 16 and b is 10. The 16 needs to be the product of two numbers that I'm looking for, and the 10 needs to be the sum of the two numbers I'm looking for. All right, so I'm going to take that 16 and I'm going to do some factors. It could be 1 times 16. It could be broken down as, well, let's look at the sum because we're not going to go any further than where we need to go. 1 plus 16 is 17. That's not the sum I want. I want 10. 2 plus 8 is 10. There, we found it. So what we're going to do is we're going to create a table. And in that table, I'm going to take my polynomial x squared plus 10x plus 16, and I'm going to write him a little differently. The x squared is going to go in the upper left corner. He's the first term. He gets to go in the first box. The 16 goes in the last box. And the 10x that's in the middle, I can write that as 2x plus 8x. The 2x and the 8x get to fill the other squares in my table. 2x plus 8x is 10x. So we split the 10x up into two pieces so that we can do the factoring. So now what I'm going to do is I'm going to find the GCF of each row and each column. So those blank spaces that I have, I'm going to find the GCF for each row and each column. So find the GCF for rows and columns. All right, top row, right here, top row, x squared and 2x, that GCF is x. Second row, 8x and 16, GCF is 8. First column, this column right here. First column, GCF is x. Second column, GCF is 2. That gives me my factorization, because what I have is x times x creating x squared. I have a 2 times an x. I have an 8 times an x, and I have an 8 times a 2. And that's how we reverse the process. So that is actually example 1 in the big ideas notes. And then in class, we went through the monitoring progress problem number 2. So we're going to do that one as well. Monitoring progress problem 2. And that polynomial is x squared plus 9x plus 8. So again, b is 9, c is 8. Here's the b, there's the c. I need two numbers that multiply to create 8. So two numbers that multiply to create 8 and have a sum of 9. So I'm going to take, I'm going to move it over here a little bit. So two numbers that multiply to create 8. I'm going to start with 1 and 8. They both need to be positive because notice both of these signs are plus. So both of my numbers that I'm looking for need to be positive. We need to remember that. I'm looking for a sum of 9. Oh, we found it already. We're not going to go any further than this because we've already got the right sum. It's 9. So I'm going to create the table. Two rows, two columns. This is how we work with the trinomial. So we're going to do x squared in the top corner, 8 in the bottom corner, the first and the last term. But the 9x I'm going to split up as a 1x and an 8x. 1x plus 8x is 9x. Then I'm going to factor, or I'm going to find, I should say, the GCF for the rows and the columns. So top row, GCF is x. Bottom row, 8. First column, x. Second column, 1. Now I have my factorization, x plus 1 times x plus 8. And I could switch the order and write it as x plus 8 times x plus 1. That would be the same thing. That's the monitoring progress number 2. Then we're going to go to example 2 in the big ideas notes. And I'm going to be factoring x squared minus 8x plus 12. Notice what we have here. B is negative 8. C is positive 12. In this case, I need two numbers that are both negative that have a product of 12 and a sum of negative 8. Because the only way a product can be positive and the sum negative is if they're both negative. So we're going to take our 12. Remember what I need for a sum, negative 8. All right, so I'm going to start with negative 1 and negative 12, but that sum is wrong. That sum is negative 13. Negative 1 plus negative 12 is negative 13. I could do negative 2 and negative 6. Oh, there it is. That sum is negative 8. I'm going to build a table with this information and my polynomials. I have x squared and 12. First term, last term. The middle one we're going to split into two pieces. So what we're going to do is a negative 2x and a negative 6x. That's these guys right here. Negative 2x and negative 6x add up to negative 8x. Okay, that's what we're doing. We're going to find the GCF of both rows and both columns, and that will get us our factorization. So top row GCF is x. Bottom row GCF is 6, but I need to pull the negative out as well. That's super important. That negative needs to come with it. So notice the negative on that first, on the x term. The first power term, got to pull the negative with it. GCF for the first column is x. Again, if the coefficient of x is negative, pull the negative with it. So we'll have x minus 2 times x minus 6. And you can check your answer either with the table. That's actually a great way to check your answer. It all works. X times x is x squared. Negative 2 times x is negative 2x. Negative 6 times x is negative 6x. And negative 6 times negative 2 is 12. And the negative 2x and the negative 6x add up to my negative 8x, which was my original polynomial right here. So it works. Third example in the Big Ideas textbook, or in the notes that we gave you, says to factor x squared plus 4x minus 21. Minus 21. And we are going to notice that in this case, b is 4. So I need a sum of 4. And I need a product of negative 21, since c is negative 21. That's my product, right? So I'm going to take that negative 21. I'm going to move over here a little bit. Taking my negative 21. I need this time, if you look at our summary, I need a positive and a negative. I need two numbers that have opposite signs. If they were both negative, negative times negative would be positive. If they're both positive, 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 positive. I need a negative, I need a positive. So we need opposite signs. One's going to be positive, one's going to be negative, right? So once we factor this, it's going to be x plus and x minus. Opposite signs. Okay? So, product of negative 21. I could do 1 and negative 21. That sum would be negative 21. Oops, not negative 21, negative 20. Right? 1 plus negative 21 is negative 20. That's not going to work. Notice what happens if I just switch the signs. My sum is now positive 20. Interesting. It just switched. I'm not going to do negative 2. I am going to do negative 3 and 7. Or I could do positive 3 and negative 7. Maybe I'll try that one first because I want to show you something that happens here. Positive 3, negative 7. That sum is negative 4. Okay, I'm almost there. I need a positive 4. So if I just switch them to the negative 3 and the positive 7, that will get me the 4 that I need. There's the one we want. I will now draw the table. Put my x squared here, my negative 21 here. We're taking the 4x and we're making it negative 3x plus 7x. GCF of the top row, GCF of the bottom row, GCF of the first column, GCF of the second column. We've got our factorization, x minus 3 times x plus 7. And we can check it with our multiplication table up there that we do have the correct answer. That was example 3. Then, we did not do the word problem in the notes because we don't have quite all the material that we needed. So we jumped into big ideas. And in the big ideas assignment, we did 3 problems. We did number 1, number 10, and number 19. So I'm going to go through those. So in problem number 1, we're now in big ideas assignment. And you do need to show work on the assignment. 10z squared, z squared plus 10z plus 21, and we're supposed to factor that quadratic. Degree 2 polynomial in one variable is a quadratic. We're going to factor that quadratic. So remember what we need. We need 2 numbers whose product is 21 and whose sum is 10. They're both going to have to be positive for this to happen. So we could do 1 and 21, but that sum is wrong. 2 doesn't divide into it. 3 and 7 will work, right? Because that sum is 10. We're going to do a quick little table. Z squared goes here. 21 goes here. We're going to split the 10z into 3z and 7z. GCF for each row and column. We're going to have z. We're going to have 7. First column, we have a z. Second column, we have a 3. Our factorization is z plus 3 times z plus 7. Done. All right, problem number 10. We have negative 6t minus 16 plus t squared. First thing we're going to do with this one, we're going to rewrite it in standard form. It's so much easier to factor if we have things in standard form. So we're going to rewrite it in standard form. Remember, standard form is where the powers go from biggest to smallest, so we're going to put the t squared in front, and the t to the first power term in the second location, and then the constant term, the negative 16, in the last location. That's what we call the constant. Doesn't involve the variable. So I need a sum of negative 6. I need a product of negative 16. One of my factors needs to be positive. One of them needs to be negative. I could do 1 and negative 16, but that sum is not going to be right. Sum is negative 15. I could do 2 and negative 8. Oh, we found it. Remember, I don't have to worry about negative 1 and positive 16 because that would just change it to a, we'll just change the sign on the sum. So this is the one that will work. And then we're going to do our table. We've got our t squared. We've got our minus 16. We've got our negative 6t is going to be 2t plus negative 8t. That's what these are allowing us to do. Split that middle term into 2 pieces. GCF of the first row, GCF of the second row. Take the negative with it. GCF of the first column, GCF of the second column. So our factorization is t plus 2 times t minus 8. And we're done. Okay, the last problem that I'm going to look at from Big Ideas is number 19. It says m squared minus 49, factor it. So that's not even a trinomial. Why is that even in this section? Well, if we look at it the right way, we can use this whole process. There is a 0 in the middle if I choose to put one, which I do. So what I need to notice is that b is 0, c is negative 49. So I'm looking for two numbers that add up to 0, and they have a product of negative 49. So I need a sum of 0, product of negative 49. Now, I want you guys to think about this. One's negative, one's positive. There's no way those guys are going to add up to 0. That's 48. What's going to happen is the numbers have to be almost the same. They have to be identical but opposite signs, other than opposite signs. That's the only way they're going to zero out. Additive inverses. They have to be additive inverses, which means 7 and negative 7 is our only option. And that is going to give me a sum of 0. All right, so we do the box, or the table, I should say. We take our m squared, put him there. Take our negative 49, put him there. I have a 7m and a negative 7m. GCF, 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 GCF. Top row is m. Bottom row, negative 7. Take the negative with it when you take that 7 out. There's your GCF. First column is m. GCF of the second column is 7. My factored form then is going to be m plus 7 from the top here and m minus 7 from the side. And we have our answer to problem number 19. And that is section 2.5 notes.